Okay, I think we can get started. Hi, everyone. Thank you for joining today's session. I am Rishav. I am an applied scientist here at Future AGI, where we are building an evaluation and observability platform for Gen AI applications. Before this, I was at Microsoft working on similar things, working with the Copilot team, helping them build an evaluation framework to understand how the LLM applications are performing in production-ready environments. So I've been in the evaluation space for a while now. Today we'll have a very interesting topic to discuss. We'll do a live autopsy of a particular RAG agent, and I think that'll be super fun. So joining us today we have Dylan from Qdrant. He has planned a super fun RAG agent demo application for everyone, and I hope you guys enjoy it during the session. Thank you so much, Dylan, for joining us today.
Yeah, thank you so much for having me.
Yeah. So before we get started with the workshop, I'll just spend a couple of minutes setting some context on what we'll be discussing today. On a regular basis, I speak with a lot of AI engineers and a lot of customers. And one of the common problems that everyone has these days is that they have tested their agentic workflows in their environments, but for some reason, when they deploy it in production environment, either it is not performing very well, or the performance starts degrading very soon. And this is a common problem across the board, right? And there are several studies that have shown that, agentic workflows do not are not as powerful as they claim to be, and only a very few percentage of these workflows always succeed, right? And hence a lot of these applications are abandoned at some point of time. Now, there can be several problems why a particular agentic workflow is failing. It could be because how the users are interacting with these AI workflow is evolving very rapidly. So as AI evolves, the how the user interacts with these applications is also evolving very rapidly. So that is something that we need to take into account. We also need to evolve our applications at that same rate. But there could be other problems as well. For example, if your knowledge base, the underlying knowledge base changes really fast, and if you have ingested the data multiple times, it can lead to a lot of duplicates in how you are retrieving certain parts of your data. Or, for example, over time, the retrieval has degraded so much that the agent has to do the heavy lifting, and it has to do multiple searches through the entire database to come up with the final answer, hence increasing the latency in for your users in seeing their final output. And there can be several other such problems as well. Now, if you're building your Gen AI applications in 2026, I highly recommend, if you have not done it already, you should have an observability layer. And we have gone in depth about these concepts in our previous sessions, where I've recommended how to set up the observability, how to set up certain evaluations. But it is of very high importance that you set up observability on your Gen AI application so that you can get a live feed of how your applications are doing in production environments. And on top of that, you can set up certain evaluations. And now these evaluations can be of different kinds. So it can be dependent on your application itself. For example, if you are setting up a voice agent, you of course need to have metrics to know how your speech to text is performing, how your text to speech is performing, but also have other key performance indicators that could be your CSAT score, that could be the empathy score for your AI agent, and these sort of things. And you need to constantly monitor and evolve on these metrics as well. Now, the tricky part here is how do you read the metrics, and that is where a lot of engineers struggle. Once you have set up these evaluations, do not themselves will help you on how you can improve your agents. So you need to understand what is the contrast, what is the gap between different metrics, and what is it signaling towards in your application, so that you can start applying those fixes. And once you have made those fixes in your system, you need to run them on some production traces, which you can use to like build your gold data over time. And you keep running them over the course of your application, so that you know that at least for these questions it still performs well. And then you keep adding back to that gold bank, so that you know that the golden questions data set also keeps evolving. So that is it with the slides. I'm not going to spend more time on the slides, and I am super excited to dive right into the demo directly. Dylan, over to you. Why don't you introduce yourself and get us started with the demo that we have?
Awesome. Perfect. Thank you so much, Rishav. So to introduce myself quickly, my name is Dylan Couzon. I've started, contributing to open source over like a decade ago. My background, as I've worked as a web developer, an app developer. Um, I worked for the longest in attribution, so at like the billion device scale. And for the past year and a half, I've been in the AI developer tool realm. So I've worked in observability and evaluation for a few months, and now I am at Qdrant. So a little bit more about Qdrant. We're a vector search engine. We're completely free and open source. We're built on Rust. We have like a pretty large community with over like 250 million downloads on Python today. And yeah, that's about it. That's about it about me. So, I'm gonna go over a few slides very quickly just to explain like the base concepts that we're gonna touch on today. So, everyone has the same baseline. So today so we have a LangChain agent that basically does like simple search using quadrants. So, so today we're basically gonna build a Pokédex search. So, you can ask questions about Pokemons, their stats or specific abilities. And so basically, the agent will retrieve documents within Quadrant. And if the documents do not sound right, the agent has the ability to search again to rephrase the query. And then once it believes it has the correct answer, it can answer to the user. And so the entire pipeline is traced using Future AGI. So for a few of the main concepts of retrieval, so basically what we do is that we take a document and we split that into chunks. So think about a Pokemon's description, stats, abilities, and then we pass those chunks through an embedding model. So that embedding model basically just maps text, so those chunks, into vectors or embeddings, which is just an array of numbers. And then we put those embeddings into a graph, a giant high dimensionality graph. And basically what happens is that things that are semantically related will end up close together on that graph. And that's basically how we then enable search. Things that we, have a very close meaning will be very close on that graph. And when we do a search, we put that same query on the same graph, and then we query, what are the closest neighbors to that query. And so this is how we retrieve the most relevant documents. There's two types of embeddings that we're going to touch on. The first are dense embeddings. So they understand semantic meanings. They understand synonyms very well. They basically understand the intent behind your query or your request more than the exact words than you used. And there are sparse embeddings. The sparse embeddings are just a keyword count. So those are very good for, exact terms. For example, you should search for the spell thunderwave. You don't want something that sounds like thunderwave or that is like a thunder wave. You want thunder wave. So this is why we're going to be using both of them in combination so we can get the best of both worlds. And lastly, so quadrant points. So, for a specific, so for example, for a specific Pokemon, Bulbasaur, sorry, I learned Pokemons in French, so you will have to excuse me about my terrible pronunciation. But basically, for a specific Pokemon, we will store multiple representations on that same point. So we will store the dense embeddings, the sparse embeddings, and also the payload, which is any kind of metadata. So, the name, the generation, etc., etc. And yeah, that's about it for, all the contexts that you need to know. So first, so I will show you what this collection looks like. So this is the Qdrant cluster dashboard. So here you can see, for example, the first points. So we have Bulbasaur Gen 1. This is the Pokédex entry. We have all the vector representations. We have the description. And right now, we have a collection that is not very clean at all. We have a lot of duplication, and this can impact the quality of our search because we have Bulbasaur for each. We have a card for each generation, and a lot of them are like duplicated. So you can see we have like tons of points for just Bulbasaur, and now we also have like the stats for it, and it doesn't get until point 33 that we're getting to a new Pokemon. So we have 32 points representing the same data basically, and so this can definitely negatively affect our search results, and this is what we're gonna dig into, measure, and then fix throughout this webinar. I'm gonna go quickly over the agent itself. So we're using LangChain, so it is a pretty like basic agent. So we're enabling the future AGI instrumentation here, so we can see all the traces in their dashboard. We'll get to that later. We're initializing the Qdrant collection, which is storing the data as points and vectors. We have our master prompt for or our main prompt for the agent. Your Pokédex assistant answer only using the documents returned by the search Pokédex tool. And then here we have different ways to search with Qdrant. So the first one is like the default one. So it is just the Qdrant client.query point. We pass the collection name. We pass the user query. Using is which embedding model we're using. Limit is how many results we retrieve, and payload is that if we want to return the payload with all the information, the name, etc. And then if we have any filters to pass. Hybrid search, we'll touch on more on that later, but this is what I talked about earlier. This is combining dense and sparse embeddings together to have a better result. And then retrieve here is just a function that adds filtering. So this is one of the fixes that we're going to implement. And then basically we have that search Pokédex function that calls whichever method we're currently using. So going into that agent right now, I can ask it any Pokemon related question. So the first question I'm going to ask, I'm gonna say, which Pokemon puts its prey to sleep and eats their dreams? If you know the answer, type it in the chat now. And so right now we're searching the Pokédex. So and we got the correct answer. So we can see that the drowsy description, if your nose becomes itchy while you are sleeping, it's a sure sign that one of these Pokemon standing above your pillow and trying to eat your dream through your nostrils. But we can see here that basically the agent did 3 searches total to get to that answer. And usually, that's not ideal because it is more LLM queries, so higher cost and higher latency. And we can see basically like the first search, the LLM just searched for Pokemon puts prey to sleep, eat dreams. And basically the first result was only like a duplication Abra and was only like duplicates from that. And Drowsy was only in 7th position. So you know, like it was there, but it was not ranked well enough because our search is not good enough and also our data is not clean enough. And all right, before we get into the fixes, so basically we have a list of golden queries, which are basically a specific question with an expected answer from the agent. And this generates our golden data sets, which is basically a calibration set that we will run before and after each fix to help us evaluate, how much each fix moved the needle. So I'm gonna hand it back to Rishav right now. So he will walk us through the future AGI dashboard to show us how those evaluation looks like.
Awesome. So, in the future AGI dashboard, once you have set up tracing, as we saw in the code, it's just a couple of lines of code to set up for the different orchestrators that are there. In this case, we were using the LangChain orchestrator. And the live questions that Dylan asks during this session are already getting traced over here. So he just asked this question, which Pokemon puts its prey to sleep and eats their dream. So we can see that it comes as a trace over here, and you can see the entire the all the spans that were there. So all the steps it took for the final answer. So you can see here that the LLM call was made and the prompt was recorded. You are a Pokédex assistant. It also made a search through the Pokédex, and it did that multiple times. So Dylan showed it on his app that it was done 3 times, and you can start seeing them over here as well. So that this provides us better visualization of how the entire agentic workflow is performing. Now you can start setting up evaluations on these different spans and different attributes at each of these steps so that you can pinpoint as to which step is performing badly. Right. So to set up evaluations here, you can set up a task. I'll create a new task and maybe I'll just name this webinar live. And I'll select the live project over here. Now, in this particular evaluation set, we will focus on any evaluations to understand how our RAG pipeline is performing. So I will set up some evaluations related to that. Some industry standard evaluations at this point are chunk utilization and chunk attribution. So chunk utilization helps us measure how effectively the chunks that were retrieved are being used by the generator model. So whether it is able to tie up different chunks and come up with an inference based on these different chunks. And chunk attribution helps us measure of all the retrieved content, how much of it was used by the generative model, right? So I'll set these up. In chunk utilization, you'll start seeing the different spans that we have for this particular project. So what I always like to do is add some filters so that the final evaluation, we do not have any noise over there. So it just helps us with, removing noise in our final evaluation. So here I will make a filter based on span kind. So I want the span kind to be of type agent, and I'll add another filter because we are only evaluating the retrieval pipeline or the RAG pipeline. I will see that the span kind should also have retrieved context. So I'll set that to is not null. So this just filters out all the spans on which the evaluation will run. And here I can start mapping the variables. So for example, in this context, I will map the retrieved context as a variable, and output is already mapped for you. So you can add that as an evaluation now. And similarly, you can add more evaluation. So I spoke about chunk attribution, but I'm not going to set that up right now. Other RAG related evaluation could be context relevance. So this measures whether the retrieved context was it relevant to the input or not. So similarly here you can map the retrieved context and the input is already mapped for you. A couple of other evaluations could be towards measuring hallucination. So we want to see whether our final LLM generated answer, was there any hallucination? Was there any invention of details over there? So we can add that in as well. The input and output is already mapped, and we map the retrieved context as a variable, and we move forward. One final evaluation would be groundedness. So, groundedness also helps us measure whether the final answer was grounded in the context provided to it. So, hallucination and groundedness are similar. Hallucination helps us measure whether there were any invention of details in the final answer, and groundedness helps us measure how much of the support that the LLM was provided did it use in its final answer. So, it mostly measures similar thing, but from maybe different angles. And one other evaluation that we will see is the answer correctness. So these are the live runs. Here we do not have the golden answers, but as Dylan mentioned, we have a set of golden questions with their expected answers as well. So we can set up answer correctness for them. So for the generated value, we map the output dot value, and for the expected value, which we do not have in these particular span, we can map the expected answers over here and run that as an evaluation. Once you have set up these evaluations, you can set the task to run on historical data. So if there are a lot of traces that are already in, you can run the evaluations on that, or you can set it on new incoming data. So if I set it on new incoming data, as we get a live feed of all the traces, the evaluations keep running on them continuously. And then you have certain other levers as well, such as sampling rate, which will, randomly sample a portion of your traces and spans and run the evaluations on them, because you might not want to run it on all of these spans, right? So for the first golden run that we just saw on Dylan's app, where we saw that there were a lot of duplicates in the retrieved context. We can see that here as well. So for this particular question, although the final answer was correct, you can see that it retrieved the same chunk starting with Delcati a few times, right? And that already tells us that my overall quality of the final, answer will be impacted, because there is no variation in the chunks, and maybe like similar chunks are getting retrieved multiple times. So for that, I want to see the aggregate results, and I can quickly go to the dashboard, and I can see that the answer correctness is quite low. We have a 0.57, 57% aggregate for the answer correctness, and the groundedness is also quite low at 68%, right? So this tells us that there is a lot of scope of improvement in our retrieval pipeline, because the correctness is still quite low. And then there are other questions as well, such as the steel our question. So here the question was, does the steel type resist ghost and dark attacks? And the answer is yes. But if you know about Pokemon, and the expected answer is that no, steel lost its ghost and dark resistances in Generation 6. But our LLM agent, gave a wrong answer very confidently. So this could also be due to, because the retrieved context, similar chunks were retrieved multiple times. But we will keep seeing this particular question through all the fixes we make, and we will see how the answer evolves over time. So yeah, back to you, Dylan.
Awesome, perfect. Thank you. Uh, I did forget to, yes, ask that question. Does the steel type resist ghost and dark attacks? But yeah, basically you can see that in generation 5 it did, yes, but in generation 6 it does not anymore. And basically the answer from generation 6 is buried under the duplicates from generation 5. And another example here, I can ask, tell me the Pokédex entry for Gengar. And so here we can see that we retrieved the type chunk for Gengar like a bunch of times, six times in a row. And the agent only looks at the top 5. So basically, this is all the information that the agent was able to retrieve. But we can see that the Pokédex entry is right here in number 7. And here, we have it. Gengar steals heat from its surroundings. If you feel a sudden chill, it is certain that Gengar appeared. So this is the Pokédex entry that we were looking for. So now, if we basically fix those duplicate chunks, basically entry will just be in number 2. So how do we fix this? So here I have just a notebook where I'm just initializing Quadrant and I have warmed up the embedding models. And here I previously ran some evals. So this is with like just a basic retrieval pipeline without like all the bells and whistles. And basically, if the data set had generation one only, we were at about at 67% accuracy. But the more data we had, with like generation one to four, we were only at 45% accuracy. And with all generations, we were at 39% accuracy. So, you could ship a RAG agent that works pretty well on day zero. But your data changes over time, and you have new data coming in, and it does affect your general retrieval quality. So it is why it's very important to have a very clean collection. So, to remove those duplicates, it's fairly easy. So right now we have like a duplicate rate of 80% just for that entry. And so here we're just basically, collecting all the duplicate IDs. So, it's a pretty easy programmatic check. And then we have the so the Qdrant SDK, we have the client.delete method that allows us to remove all those duplicated IDs. So I removed about, I believe, like 16,000 IDs just in like a second or two, and now if I you know ask for tell me the Pokédex entry for Gengar, we can see that we get the correct information here, and the Pokédex entry was just in like second and third position. So the agent was able to now get the correct information, and the quality of our retrieval has greatly improved just by removing those duplicates. But these are some of the numbers that we have here. So those scores are basically zero point 0.5 is no better than random. And we can see that we've increased from 0.57 to 0.76. Oh, I'm seeing that. Oh, I did not share my screen correctly. Excuse me. So what you were not able to see earlier, I apologize. So this is the graph that I was talking about. So basically the quality going down. And also this is the simple programmatic call that we run and the result metrics. But I'm gonna pass it back to Rishav now, where he can show directly the improvements in the future AGI dashboard.
Yeah, so after applying that deduplication, we can see that some of the metrics have improved significantly. Our chunk attribution has reached a good score, chunk utilization is similar, hallucination has improved a little bit, but the metrics of significance, groundedness, it has increased quite a bit over here, and our answer correctness has also increased quite a lot. Right. And if we see some of the traces, just to understand what happened over there, we can see that if we have to understand what were still some of the problems. For example, here the question was about a Pokemon that sleeps constantly and gains weight from eating without exercise. We can see here that after deduplication of we get diverse chunks at currently, right? And earlier we saw that all of these were duplicate chunks. One of the issues that is still over here is that now that it is getting diverse chunks, one of the questions in the golden set was the electric mouse Pokemon that stores electricity in pouches on its cheek. So we see that similar like relevant chunks have been retrieved. So it retrieves something about Pichu. The electric pouches on its cheeks are still small, and about some certain other Pokemons as well. Match doing semantic match, but the final answer was not correct because it says that based on the search results you are describing Pichu, but the correct answer was Pikachu. It stores electricity in the pouches on its cheeks, right? So this points us towards that while now it is retrieving diverse and relevant chunks, maybe it is getting confused or it is not able to differentiate well between the different chunks, or it is getting confused between the different characters because there is not enough information that was encoded when we used certain sparse embeddings. And that is where our next fix comes in. Maybe we can provide more information within the embeddings so that it is able to retrieve correct information on Pikachu and then answer these questions as well. Dylan, do you want to show us the next fix?
All right, perfect. Yep, so for the next query, the electric mouse Pokemon that stores electricity in the pouches on its cheeks. So the answer that we're looking for is Pikachu. And here we can see that the agent answered Pichu. And Pichu, the electric pouches on its cheeks are still small. They cannot store much electricity yet. So basically, we're currently using an dense embedding model with 384 dimensions. So this is considered, like a fairly small and efficient model. So, it is usually fast. Those embeddings, are very easy to store, and you they do not take a lot of space. But sometimes they still struggle to understand the actual semantic meaning of a sentence. And so here, it struggled to understand negation. So basically, cannot store much electricity yet, and it had, pouches and cheeks. So basically, it thought, this was like the same sentence. So the fix that we're gonna do, basically, we're gonna be upgrading to a stronger embedding model. So the one that we're using at first is called Mini LM, and we're going to be upgrading to a model called BGE. So to do that, yourself, basically, you would have to call Qdrant, so like the clients dot creates vector name, and then clients dot updates vectors. So this is something that can take a while depending on the size of your collection. So what we have done here is that basically on each point we had both of them. So this is like mini LM with a length of 384 dimension, and here this is BGE with a length of 1024 dimension. So now we're basically gonna switch to dense strong, and so that allows us to make that switch very quickly. Um, And so here we can see that so like the recall at 5 is basically the score. It's the fraction of relevant items that were returned, and we can see that mini LM it was 0.64, and with BGE it was 1. So watch 1, which is perfect score. So now we're going to uh, do that same search again. So here we just upgraded the embedding model, and we can see here that the electric mouse Pokemon you're describing is Pikachu. According to the Pokédex, Pikachu stores electricity in the pouches of its cheeks. Okay, this is exactly what we're looking for. And yeah, so sometimes just upgrading your embedding model can really increase the quality of your retrieval, and often it just comes at a cost of a higher latency and also can uh, increase like the storage cost. Um, and since Rishav, you've already showed that query in future AGI, I'm gonna move on to the next fix, and then I'll hand it back to you for after that. So basically now we're going to add hybrid retrieval and re-ranking. So hybrid retrieval is what I talked about earlier, is combining those dense embeddings that understand semantic meaning and those sparse embeddings who does a great keyword matching. And so uh, for it really enables us to get the best of both worlds and to even further improve the quality of our retrieval. So here a Pokemon that crawls up surfaces using adhesive feet on its short legs. So it is a very, you know, semantically difficult queries or question to understand. And so here we still got Caterpie. We still got Caterpie, you know, in the top five, and the agent was able to, to find the correct answer, but we have like a lot of noise, and we have a lot of other Pokemon who rank higher. And so, as we've seen it before, basically this is a simple quadrant query for just dense embeddings. So we do client.query points. And when we want to do hybrid, so what we do is that we do a prefetch. So we do a prefetch with the dense on the dense vectors, and we do a prefetch on the sparse vectors. We retrieve 20 of each, and then we fuse them. So basically, we fuse the scores, and so it becomes, the first result of dense with the first result of sparse, the second result of dense, then the second result of sparse, etc., etc. And we keep the top 20 here. So we could stop here and, it would already um, clearly improve the results. But what we're gonna go a step even further, and we're gonna use a late interaction model called Colbert. And basically, instead of turning, a sentence and a query into vectors and comparing them, what Colbert does is that it turns every single tokens from the queries and the answers into a into an embedding, into a vector, and then it compares basically token by token and does a maxim. So it basically gets the highest score of averaged. And so Colbert is something that, we don't want to do over our entire data set, over our entire collection, because it is extremely costly to just, embed every single token. So this is why we're only doing it on the results from the prefetch. And now, once we apply this, so instead of doing a single dense query, we're now doing a dense query, a sparse query, fusing them, and then re-ranking through Colbert. And now, when we do that query again, so the agents should still be right, but in the retrieve chunks, Caterpie should be much higher because we have a much better semantic understanding of the query. All right. I have been having some DNS issues lately, and it was not acting up until now. So it's supposed to be slower. It's not supposed to be that slow. It is an issue on my side. So I'll hand it to Rishav to show us the dashboard, and then I'll
Yeah.
show the results after.
Okay. So let's look at the aggregate results first. We can look at both the runs that Dylan just did. So with the fix for that we made with the embedding model, there was a significant improvement in our answer correctness. It went up to 92%. Groundedness was also quite high. It went up to 92%. But then we applied the fix for re-ranking, and some of the metrics hold. So our context relevance reached an all-time high of 99%, which was expected because now there is relevant context with better ranking as well. Chunk attribution had already saturated a couple of fixes ago, and chunk utilization is also good enough at this point at about 87%. But with the re-ranking fix, two of the metrics went down. The answer correctness went down from 92% to 86%, and the groundedness as well went down from 92% to about 84%. So now let's take a look at certain traces to understand what might have happened and why did the answer correctness metric or the groundedness metric drop. So once we go through certain traces, we see that what is happening at this point is because the LLM is getting a lot of relevant content. Earlier that was a problem, and even with these relevant chunks we are ranking them quite well with our re-ranking techniques. What is happening is now the generator is getting confused into which is the correct answer. So between the different chunks, it is not able to, identify the correct answer, or it picks one or the other chunks, thinking that both of them might be correct. So, for example, in this particular question, a Pokemon that rolls into a spiky ball to defend itself or get away, you can see that the first retrieved context itself, Sand Slash, which is the correct answer, was curls up into a spiny ball when threatened. Uh, but the LLM answer, the output, was something on based on search results. The Pokemon you're describing is Sandshrew, which wasn't even the first retrieved context, right? It was maybe the second one, Sandshrew rolling into a ball and bouncing, but somehow LLM decided to opt for that and use that in its answer rather than Sand Slash. Right, so these are the problems that start coming up now that your retrieval has a good quality. The generator behavior starts popping out where it can, get confused into similar chunks, or where it does not have, enough metadata to understand whether, one character was an evolution of the other and when did this evolution happen, so that it can answer the question correctly. So on the steel arc question, from the last couple of runs, I just want to show it. We are still getting wrong answer. So again, you will see here that does the steel type resist ghost and dark attacks? Again, it tries to hedge that based on the search result, the answer depends on which generation you are asking about. In one generation, it does this. However, in the answer, we know that in generation 6, it was resisting, it doesn't resist, and in generation 5, it was resisting. So that is the target answer that we are looking for, and there is still scope of improvement to reach there currently.
All right, perfect. And yeah, so for our final fix, it's like that question for Pokemon, I think could be considered, very correct because not everyone plays the most recent generation at all times. But in some use cases, you want to serve your users only the most recent information, and you don't want to share outdated information. So, sometimes, for example, here, if we want to serve information for the most recent generation, but maybe we don't want to delete information from older generations. So here we have Bulbasaur Gen 8, which is the most recent one, and basically we have that flag that is current equal true here. So basically, with that flag, we know that it is the most recent information. So now, what all we need to do is basically when we do a search, we can look for that flag is equal to true. And so basically, here this is exactly what we do. So when you create your collection, you would want to call that Qdrant client dot creates payload index, and you put the field name is current, and or anything you want to call it, and then you set it as a boolean. And then basically you just have to add that to your search inside of your filters. And now basically if I type the same question, we can see that current only is enabled. And now here it should only answer for generation 6. So those filters can be enabled for anything. We have a lot of people who uses it, for example, for e-commerce to filter by a specific brand or category or price range. We can even do like location for any kinds of use cases. So this is not only limited to Booleans. Uh, and here we can see that finally, no, the still type does not resist ghost and dark attacks. So this is the answer, that we were looking for all along. So with the most recent information.
Yeah, so finally we have the right answer.
Yes. All right. And that was everything for me on my end. I know we do have a lot of questions. Um,
So let me start with some of the questions. Uh, Uh, Tim is asking, there are a lot of options in terms of strategy for each step of the rack pipeline, like document parsing, cleaning, chunking. Is there tooling that you use to run experiments and find the best ones for given constraints, or you just go with the same strategy most of the time? So I would say that if you are trying to experiment with, different parts of the retrieval pipeline, you can set up like a controlled experiment where change one part of the pipeline, run similar set of evaluations on a set of golden questions on both of them, and then see what the differences are and how you see the metrics evolve. If you feel like one of the metrics have gotten better with this particular change, you can go ahead with that, but also keep in mind that as you keep making subsequent changes, as we saw in our case as well, after the re-rank change, there are certain metrics that could go down. So you might have to, keep going back to different things and then pick the right set of choices so that you know that the final answer has is most accurate. Dylan, would you like to add anything to it?
yeah, absolutely. This is why we we do our best to be like a very composable vector search engine because there's not one solution fits all. As you saw earlier, when I enabled hybrid search and re-ranking, actually some evals went down. And it did, make our retrieval quality worse in some ways. And, it is a technique that was supposed to make it better. So yes, unfortunately, there's not one method that if something works for someone, it doesn't mean that it will work for you. This is why, we're not opinionated at all. And you kind of have to find what works best on your use cases and data sets, and also, what constraints you're able to tolerate.
Okay. Next question from Alex. How should teams evaluate the quality gain from re-ranking against additional latency and cost? So one of the things that we also saw in the session was that earlier it might have to do searches a couple of times, but we went from maybe three searches for one question to like one search per question, which reduces the latency, but there can be additional latency added due to re-ranking itself or how you are now retrieving based on, if you're using higher dimensional embedding models. But that is something that is based on your application. If you want your application to be very fast serving, you can take that call based on, what the use case is, but always know that there can be certain trade-offs with accuracy, but there are ways to like get around it as well. Dylan, what would you like to add?
Yeah, no, you summarized it pretty well. It's all a trade-off, and it really depends on what is the most important to you.
Okay. Tim is asking to measure retrieval, recall, and precision. Would you recommend to have human label relevant chunks and augment chunk labeling with a tuned LLM judge? So I think like doing human labels at this point can be very prohibitive. Also, if you're doing it for like chunks, that can be a lot of data, especially if you are dealing with large data set sizes. So a good way to for chunk labeling, I think I would suggest you can go with something like LLM as a judge. They can give you maybe 80%, 90% accuracy, and that should be good enough for you to get started with. Any other thoughts, Dylan?
Nope.
Uma has asked, how do you evaluate cases where the correct behavior is to abstain or say that information is unavailable? Dylan, I would like you to take that.
Yeah, absolutely. So, this is usually more a question for, you know, the basically the agent framework. This is something that should be, handled at like the lang chain on the lang chain side, because for us, we're just a retrieval engine. But something, some signals that can be relevance is that, if the retrieval score is, or like the retrieval confidence is pretty low, or, sometimes if you have like one result that really stands out and differentiates itself from the others, you might, it there might be chances that this, we're very confident that this is the correct result. Um, but yes, this is, something that is more done at like the framework and LLM side.
Okay. This question is more quadrant related, I think. Dishant is asking, deleting is okay. To dedupe, is there no native distinct like construct in quadrant to get distinct points? Or we could use hash to dedupe.
Um, that I am not sure off the top. Don't want to share information that is incorrect. But no, I don't believe we have a native distinct value uh, in quadrants. But there might be alternative methods.
Okay. Christopher is asking, I'm interested to hear if you have opinions about the size of RAG impacting the quality of output. If so, would a mixture of multiple RAG mitigate that? If by size of RAG you mean the size of knowledge base, yes, again, I mean that could of course impact the quality of retrieval because you need from a very large database, it always gets very difficult to, have diverse data points. And for that purpose, you need to have a good embedding model in place. And using mixture of experts for RAG with the current models, I think might be an overkill because the current models are, good enough to use the provided context and come up with an answer. So yeah, I don't think we need to use mixture of experts, but Dylan,
Um, yeah, I think, size itself isn't the problem. It's more the noise is. And, because more documents means more near duplicates or irrelevant chunk competing for, the top five results. And so, kind of the lost in the middle problem gets worse as the context grows. So yeah, maybe splitting into multiple smaller like domain specific indexes and routing the query to the right one can beat like just one giant index, and also in terms of like latency, storage and scaling headache. So each pool gets stays precise instead of getting diluted.
yeah. Someone has asked for evaluating, do I always need golden data sets on platform like Future AGI? On Future AGI, you do not always need golden data set because production environments, as we saw, are not going to have a golden or an expected answer. So that is where, something how it depends on how you are reading between these different metrics because the metrics that you have set up, they tell you a story and you need to understand and read the explanations as well. Or you could use something like an error feed that we offer that will tell you right out of the box what are the problems with your system, and then you can start fixing them and see how they respond. Uh, Let me see. Renan is asking what you guys think about using agentic development method to create rack system, perhaps loop engineering or only an SDD workflow. I do not have like any major opinions on this, Dylan.
Sorry, which question was this?
So, what do you think about using agentic development method to create RAG system, perhaps like loop engineering to create a RAG system itself.
Yeah. So, you know, Claude work Claude works, sorry, Claude writes most of my code today. I'm gonna say that, at the end of the day, you are the engineer and you are the person responsible for the code that you put out. And there are people who manage to, who writes manually great code, and there are people who write manually terrible code, and there are people who uses AI to write very well tested and very well and code with like a great architecture. So yes, I think, if AI is very good at like doing A/B tests and benchmarking, and if you really have your like meaningful good golden evals that you have a training and a test set, and that you have all your guardrails and evals in place. I do believe that, just basically an agent running in a loop and testing and finding the best methodology can build a great RAG pipeline.
Okay. I think we are towards end of time.
Yeah.
So I just want to summarize that we did a live, autopsy of an agentic workflow, and we took the accuracy from about 50%, 52% to 92%, which was quite a jump. But that was just a demo setup. But it was more to give you an idea of how you can, understand what is going wrong in your setup, look at the metrics, look at the traces, because both of them combined give you the information. There is no one way of building these things, so always try to understand these eval metrics from different perspective. Try to see what's going wrong with live data as well, and then make changes in your system. Dylan, any parting thoughts, any final thoughts for the audience?
No, thank you. Thank you so much for having me. I had a great time. I'm sorry we were not able to answer like all the questions, but feel free to, find me on LinkedIn. We also have like a Discord community, Qdrant Discord. I'm pretty active on there, so, just ping me and I'll be happy to answer any follow-up questions.
Likewise, we also have a Discord community, so please get in touch with us, and we are always super happy to chat with anyone. Thank you so much, Dylan. I learned a lot about Pokemon. It was
All right.
interesting setting up this with you. Thank you so much.
Thank you. Bye.
Bye.